Number 10 says the graph of this quadratic function is shown. What is the value of a? So to be able to find this value of a, I can go to my vertex and to the next coordinate point on either side. This coordinate point is 1, 2, 3, 4 units down and 1 unit over. So I know that this a right here, the slope of that essentially is 4 over 1. Then I need to look at my arrow markings. My arrow markings are pointing downwards where y is negative. So because we're pointing towards negative, this 4 will need to be negative, which means J is your answer for number 10. Number 11, they give you, the table shows the values for the quadratic function h. Which statements about the graph of h are true? I can solve this a couple of ways. And one way that I would like to do this is by adding a list in a spreadsheet and just looking at a scatter plot. So again, I'm going to put x at the top next to y. And then I'm going to write down -4 in my data table here. Okay, and that last digit is a 9. So be careful on that. And then we have 44. Okay, so now we have all of my data in. And I want to insert real quick. Now that you've got your data on, you can go to Menu. You're going to want to go to the data and then go down to the very bottom where it says Quick Graph. It's going to show you a quick scatter plot here. We're going to put on the y-axis, we're going to put in the y variable, and then on the x-axis, we'll put on the x variable. That gives us a really good picture of what's going on, and we can start answering some of these questions. It says the parabola opens down. That's clearly not true. You can see that this is opening to the positive side. So option 1 is not true. The axis of symmetry is actually right here in between these two dots, and you can see that that does happen at 3. So where it asks you the axis of symmetry is x equals 3, that is true. The y-intercept is where x equals 4, or excuse me, y equals 4. If that were true, then you would also be able to see when y is 4, x should be 0. So that's one that we need to give some more thought to. And number 11, it says the minimum value is -6. So we can look again on our data table here, and hopefully we're going to be able to see the negative 6 bottom value here. Since we can't really see that, we might actually need to go back in and take a look at the equation. For now, we're going to look at going to data. And again, from here, you've got your graph. You can go to document. Here. I'm going to go to data, statistics, stat calculations, and then a quadratic regression. We named these x and y, and it should spit out our answer in C. Now I'm going to go to document, insert a graph, and I'm going to hit up 1 time. And when I do that, there's my equation that pops up right there. So now we can see very clearly the y-intercept here does happen at when x is 0, y is +4. So this happens on number 2. Number 4, it says the minimum value is -6. So I'm going to go Menu, Analyze the graph, find the minimum point, and my lower bound will be here, my upper bound will be here. And we can see that the minimum happens when y is -5. It says that it happens when it's -6, which is not true. So that means that 2 and 3 are the only ones that work out for us, and option B will be our answer there. And I can run another regression on number 12, which just gives me a data table and a few equations. So I will go first just to get a new document set up. Then I'm going to add in a list in a spreadsheet. And type in my data. Now that all my data is in my table, I can hit Document, look through my list. I'm not really seeing what I need. I'm going to go to Menu, hit Statistics, Stat Calculation, and then run a regression. Maybe this is a quadratic regression. So I'm going to try that first. We got X and Y. And then we want to put all the answers in C. That looks good. Now I have my equation. Document, Insert, Graph. It draws my graph for me. I'm going to go up once, and then I'm going to hit Enter. Okay. I'm going to ask it to find my equation for me, my graph, and here it is. I've got 1.357x squared minus 3.429 plus 37.6. When I look at number 12 and I look at all of my answer options, the one that's closest to this is going to be F. And where it says 1.357, they've rounded it to 1.36. When it says 3.429, that's minus 3.4. You can't really see it on the video, but it's plus a minus, so that negative is in there. And then plus 37.6, they rounded it to 38. Very last question on this page says the cross-section of a parabolic radar dish can be modeled by this equation. How many inches is the receiver from the vertex? And so you have your satellite dish. It's got the receiver on it. And basically what they're asking is, okay, if this is the vertex, how far away is the focus? Great question, because we know the template here is y equals 1 over 4p x squared. So these two fractions must be the same. They must equal each other. So we can say 1 over 4 times p equals 1 over 216. To be able to solve this out, we can do this a number of ways. Let's go ahead and multiply through first. If I multiply this side, the right-hand side, by 216, I will get rid of my fraction, and I'll just be left with 1 equals 216 divided by 4p. Another way to do this, or think about this, is to just multiply both sides first by 4p. When I do that, of course, that equals 1. I'm going to have 216 on this side and 4p on this side. Well, 216 divided by 4 is going to equal 54. So p equals 54. And this is what is going to go into the griddable. 54 is the distance, how many inches that the parabolic vertex is from the receiver.